So now we'll go through costs, because obviously it's great to do all these great things, it's great to get all the comfort benefits, all the other benefits, but if it's not cost effective, it's a harder sell. So obviously there's going to be more upfront costs. You're spending more on the materials. So what first thing you need to do is you need to stop thinking about just the capital cost to put on your mortgage. You need to start thinking about the life cycle cost. How long is it cost? How much does it cost me to build it and live in it? So maintain it, operate it, repair it, pay utilities for 40 years. And as soon as you do that, passive house becomes the lowest cost option. So this is reported out of Germany using 8 cents per kilowatt hour. Obviously we're a little more expensive here, but it won't really change it that much. So the big green one, the investment cost, passive house costs more up front. The maintenance cost, I believe they've left the same, just for comparison purposes. I could quite easily argue that maintenance cost on a passive house is going to be less because you're choosing materials that are more durable, you're building it in a more precise way, there's less likelihood of damage. But for that, they just left it the same. And then you see that the utility, the red heating energy cost or utility rates, significantly less in passive house. So over a 40-year, the total cost is less. So a little more details into that. This is the Valley View again. So the Valley View Town Hall, built in 1970 or so, was no longer meeting the needs of the town. So they brought in a consultant to look at options for both replacement and renovation. And interestingly enough, the cost to renovate was $2.63 million. The cost to build new was $2.8. So after only like 40 years, that building is basically a throwaway building. It's going to cost you more to bring it up to code and make it comfortable than to build it new. So they thought, okay, this is a pretty good time to, if we're going to build new, maybe let's go more energy efficient. What would that look like? So what they did is they put in the RFP, the request for proposal that they sent out to various bidders, that you get bonus points if you build a passive house. So a consortium down there of builders put in a bid, building to the passive house level, and it cost 10% more, $3.1 million. So the other really interesting thing is that when this came out, this was like kind of in 2014, so energy efficiency was fairly new. So they actually went to energy efficiency, and they got energy efficiency to give them a grant for $300,000. So obviously you can't do that all the time, but there's definitely bonuses to being first. So this is kind of the passive house planning package sheet that spits out all the details. And what they did is they did some analysis on it, and they actually found that they could go to Passive House Plus. So what is Passive House Plus? So Passive House Classic, that's the one that's been around for 30 years. A few years ago, they came out with Passive House Plus, and it is basically net zero. So you start with the same passive house building envelope, but now the cost of renewables over 30 years is now fairly cheap, so putting on solar panels makes sense. So they designed the Passive House Plus certification program to basically be the equivalent of net zero, and then they designed the Passive House Premium certification level to be essentially net positive energy. So you put on a few more solar panels, and you can actually create more energy on a net annual basis than you use. They also looked at some of the other things that were going on, about the renovations and a few other things, and they came up with 2 other certifications. So the first one is that EnerFit that I mentioned before. So EnerFit is Passive House's design standard for renovations. And if you notice, the max for the heating demand is no longer 15, it's 30. So they realized that to renovate a building, yeah, you can add more insulation above grade, you can change the windows, you can add more insulation to the roof, you can somewhat cost effectively add more insulation to the foundation, but you're not going to get the insulation underneath the slab. So if your basement is deep enough, you could put insulation on top of the slab, but because of thermal bridging and a whole bunch of other things, it's really tough to get a renovation to 15. So they say, okay, you're right, that's fine, but they've now, because they're Germans and they will think about it and test it and analyze it, by saying 30 works as a standard, you still get all the comfort, the quiet, the air tightness, and all the other benefits that come with Passive House at a higher energy demand. It's still 80% better than code minimum. But because it's 30% or 30 instead of 15, it's a little more cost effective because you don't need the best of everything. And you can do it with renovation. So they also at the same time came up with Passive House Low Energy Building Standard. PHI Low Energy Building is I think, designed to be kind of a consolation prize. Passive houses that didn't quite make it to 15. Like you really tried really hard, maybe you got 18 or 19, you couldn't quite make it to the 15. So they came out with a passive house low energy building. But what we have now found, and again, by making that a standard, they say you still get all the comfort and quality benefits out of it. And remember the habitat buildings where they were kind of designing to kind of the 25 kilowatt hours? So what this also does is it now justifies or backs up what all the Edmonton net zero builders have found through their trial and error, that you can still get a very high quality house building to kind of the 15 to 30 kilowatt hours per meter square range. And again, you now don't have to use the best of everything, so it becomes more cost effective. So back to Valley View Town Hall and their Passive House Plus project. So they wanted to put a number to the various types of energy they are using on site and compare it to the code minimum office to the Passive House standard. So space heating, cooling, domestic hot water, lighting, you can see all of them have a fairly high reduction from code minimum. And then since we, at the time, had a carbon tax, we didn't have a carbon tax for about 6 months, now we have carbon tax again. So they calculated the annual greenhouse gas emissions savings from going Passive House from code minimum, and then they put the actual number against that. So they put all this is the cost to do it code minimum, this is the upcharging cost to go to the Passive House, and then you also put a cost to the greenhouse gas savings. There's your combined costs, and then using a simple payback method, so it doesn't include as much escalation, it kind of fixes a price for your mortgage, it fixes a price for utilities over a length of period. Your payback to go from code minimum to Passive House was 18.5 years. And your payback to go from code minimum to Passive House Plus, which basically you add another $60,000 of solar panels, is 17 years. You're like, what? That's less, but you're paying more money up front. But you're net zero, and all those solar panels are producing energy that you're selling back to the grid. So your utility bills are dropped down even more. So you pay more up front, but utility bills are even less. So 17-year payback. So if the city of Calgary, City of Edmonton, wanted to spend some of my tax dollars to build a new building, and the simple payback to go Passive House was 17 years, I'd be fine with that. Like that building should sit there for 100 years, 200 years, and basically utilities are free. So once those 17 years are up, there's basically no costs or very low utility bills. It's not zero because it's not ever even selling and buying, but drastically reduced utility costs. So I don't know, that's a pretty good argument for me. You have to think about it differently. Talking just about the construction costs. So this is just construction cost increases in various locations. So obviously Germany's been doing it for 30 plus years. They're pretty good at it. They've got the additional costs down to 3 to 6%, which really 3 to 6% is kind of about the cost of high to low end finishings. So very, very reasonable. England is obviously, again, a very cool temperate climate because they're an island. They haven't been doing it for 30 years. They've kind of about, even a little less than us, or maybe 5 to 10 years, they've been in the Passive House kind of business. And they've got it down to 5 to 13%. Going to Vancouver, that's a really interesting one. It's 0 to 3%. The reason it's that low is because, again, Vancouver is a very warm climate. And also what Vancouver has done as a city is their code is a lot higher. So code minimum for walls in Alberta is 17.62. Code minimum for walls is R22. So kind of the cost of Passive House doesn't change, but as the code comes up, the differential decreases. So that's why just in Vancouver, it's 0 to 3%. In Alberta, again, we haven't been doing it that long. There's not a ton of examples, but we're estimating kind of the 5 to 15% upcharge. The 15 would be kind of your first build. As you kind of optimize it and get better at it, you could probably drop it down to closer to 5%. And then the other interesting one, which we'll learn about a bit more, is Pittsburgh. Pittsburgh is, again, colder than Vancouver, but warmer than here. But they do get to minus 15, so they do have to worry about actually freezing and in cold temperatures. And they've only been doing it, again, kind of 5 to 10 years, and they've already dropped it down to a 3 to 5% increase, which is really impressive. And we'll see how and why they did that in a few slides. This is all based on Passive House Classic, because the Passive House Plus premium, EnerFit, and low energy building has only been around 2 years. There's not enough data to make any statistically accurate estimation. But no one buys a house for cash. So the upfront cost of a passive house is really only half of the equation. What is most important is what is your monthly operating cost. So it's the addition of your capital cost, which you put onto a mortgage. So it's your monthly mortgage rate plus your utility bills plus probably your property taxes. So you want to add up those three things and see what that number is. So this is an example from Victoria. So it's not Vancouver. So the upcharge to go to passive house here was 6%. And what cost him more was the envelope. He spent more on the building envelope, cost him an extra $30,000 to build to that level of envelope. But his mechanical system was a savings. So he saved about $15,000 in his mechanical system over a code minimum. So the net premium was $15,000. And his square foot cost is lower, but the same kind of ratios would still work in our climate of higher square foot costs. So when you take that extra $15,000, put it onto a mortgage, it costs him an extra $400 per year of the mortgage, onto the mortgage. But his utility savings from going to passive house was $1,400 a year. So from the day he moves into that passive house, he is saving $1,000 a year versus a code minimum building. So this is what we call a perfect passive house, where the addition of your monthly mortgage and your monthly utility bills is less than or equal to a code minimum house. So that's how you kind of sell passive house. That's obviously a warmer climate, so does that work here? So remember we talked about the mechanical system needs to be the cost savings in your house. And the reason for that is, so if you take that 15 kilowatt per hour, that was the performance metric, you times it by 185 meters, which is a 2,000 square foot average house in Alberta. Say electricity costs 15 cents per kilowatt hour, your space heating cost for that 2,000 square foot house is $416 a year. What if we went all the way to the passive house low energy building standard? So that 15 turns into 30, the rest of the numbers stay the same, so it only goes up to $832. So basically the difference between passive house classic and passive house low energy building is $400 a year. So because of that, using the passive house low energy building standard is the most cost effective, because it doesn't cost you much more on energy, but you can save a lot more on your building envelope. And that's also why we now say that kind of the basic, inexpensive, easily replaceable electric resistance heaters are probably your most cost-effective heat source, if you're not going for net zero. Because they're cheap, you stick them on a wall, if they break, you get rid of them and buy another one. The mechanical system needs to be the cost savings, and the PHI low energy building is your most cost-effective option right now. This is my house. So PHPP will spit out a total energy use estimate for the year. And my house, it was 19.1. I've lived in my house 3 full years and we've kept all the data. So on average, we've used 20.6 megawatt hours per year. So the question that always comes up with energy models is, are they actually predictable? Are they accurate? 19.1 was the estimate, 20.6 was the actual. To me, that's pretty darn accurate. So I have faith that if the data is entered correctly in the passive house planning package and you build it to what you designed it, your energy will match. So if I built my house to code minimum, because I'm a bigger house than a code, so the standard code, average code, I'll use 53 megawatt hours, and the average single family home, 2,000 square foot single family home in Alberta, uses 40 megawatts. So again, I have a 65% reduction in total energy use compared to a single family home, and I'm a duplex. I have a single secondary suite in my basement. That only gives me a 50% reduction in my monthly utility bills. And that's the difference. Those numbers will never match because you have all your fixed connection fees and you have your fixed transmission fees, you have the non-variable portions. But that's still a fairly large reduction. I save $210 a month on my utility bills. So this is the other way to sell passive house. You look at the mortgage. So here's a mortgage, various mortgage amounts. This is the monthly payment, given 3% interest on a 25-year term, to service that mortgage. And then, if I increase that mortgage amount, this mortgage amount by either 5%, 10%, or 15%, this is how much more that mortgage will cost me each month. So what you can see is, remember, I'm saving $210 on my utility bills every month. So everything above this line is a perfect passive house. My utility bill savings is the same or more than my increase in the mortgage. And for the parts below the line, the kind of higher mortgages and your kind of 10 and 15% increases in capital costs, here it costs you an extra Tim's coffee a day, and for the other ones it costs you an extra Starbucks coffee a day. So it does work in Alberta as well. The other thing you can do is, again, every room in your house is comfortable all year round. So if you're going to build a basement, move one of those offices or your bedrooms that was on your third floor into your basement. And if you take that out on 3 floors, like 100 square feet times 3 floors, you've just reduced your square footage of your house by 300 square feet, which on a 2,000 square foot house is kind of 10%. So that's the other way to get rid of around that problem, is make your house 10% smaller, your mortgage will be 10% smaller, and that's the other way around it, is use your basement for more than storing your junk. If you're going to build it, use it for something. And if you're, what I say now is, if you're rural and you have lots of space, the most cost-effective option is actually a slab-on-grade. Like an insulated slab-on-grade with a 2-story house that's more compact. That's your most cost-effective option if you have lots of space. If you're in an urban setting where your land costs a lot more for only like a 33-foot lot, then it justifies building a basement. But use that basement for something more than storing junk. Or build a multifamily. So this is a multifamily. This is a Radiance co-housing. It's in Saskatoon. And the passive house, building that building to passive house, added 6% to their construction costs. And it opened in 2018. Has a bunch of solar panels on it. I don't know if it's quite net zero, but it's probably pretty close. And again, they opened in 2018, so they've only just done a year of data to know if they're actually net zero. So Michael Nemeth designed this one. He is an excellent mechanical engineer and certified passive house designer, probably one of the best ones in Canada. And he designed and lives in it now. And he says, if we do things right, we can save money. We can build a net zero energy building for almost no extra cost. That's what we're finding on our bigger projects. It's not about giving things up. It's about gaining comfort, gaining resilience. So what happens then every time you have a multifamily is 1 or 2 of those exterior walls is no longer an exterior wall. It's a shared wall to your neighbor. So the cost is the same party wall that would have been there as a code minimum. So now instead of having 6 walls that have to be built to the passive house standard, you only have 5 or 4. So again, that reduces the cost. And what they can also, I believe, have done here and can do here, since this is co-housing, is they might share 1 larger utility connection. So they only have a lower, like 1 connection fee as opposed to 18 connection fees. And I believe they also are having kind of 1 larger heat pump hot water tank servicing 2 or 3 buildings. Because again, the demands are so low, the more commonly available and more cost-effective equipment that's bigger or too big for a passive house is perfectly fine for 2 passive houses. So that's the other way. And then remember Pittsburgh and Philadelphia with their 3 to 6% increase. This is how they did it. So this is the Morningside Crossing. It's a 46-unit affordable housing complex built from a renovated 1897 school. I'm guessing they only kept a little bit of the facade and everything else is new, but it is a renovation. And it's one of 23 multifamily passive house affordable housing projects that Pennsylvania, or the CMHC equivalent of Pennsylvania, has funded. And what they found is that Morningside Crossing came in below the average cost of other government tax credit projects. So that they're saving money. So what are the key takeaways from that? In 2014, the funding organization, basically CMHC or Edmonton Housing or something like that, made a change to their competition criteria promoting passive house. So they didn't make it mandatory. They said, when you do the RFP, we're going to give you bonus points to be Passive House. And they gave 10 bonus points out of, I think, a total of 120. So the people that are bidding on it see that, want the project, so they figure out how to build the Passive House because they want the project. And then you do that 23 times, and then all of a sudden, a lot of the industry knows how to do it. A lot more of the products are built, sold, and the prices start to come down. And that's how you get Passive House down to 3 to 6%. So PACE financing. What PACE is it's property assessed clean energy financing. So what it is it gives you a loan against a clean energy or an energy efficiency upgrade on your house, and the repayment of that loan is tied to your property taxes. So which means the default rate's very low because it's hard to not pay your property taxes. So the insurers like it because it's very low risk, so they give you a lower insurance rate. And as a homeowner, if you put solar panels on your roof, there can sometimes be the concern like, am I going to get my money out of this when I sell my house? Well, you don't have to worry about it because the cost of that loan to put the solar panels on stays with the house and the property tax. So it's been used to great success in the States. Alberta passed the legislation to allow it here in the beginning of 2019. And even with our new government, because we're Alberta, we can't call it PACE. We had to come up with our own name. It's Clean Energy Improvement Program. It works exactly the same as PACE. It's just not called PACE. But the program exists. It is administered by Energy Efficiency Alberta. So Edmonton wants to do the pilot project. They did have a bit of concern about Energy Efficiency Alberta being the administrator of the project, but they are a defunded organization. And this is like a 25-year, at least, kind of commitment. But they've sorted that out. They've got past that point. They have written the bylaw to allow them to enter PACE as a city. And very shortly, probably the next, talking to the City of Edmonton people in the next kind of 6 months, they will be offering the first, I think, 20 or 25 residential pilot projects for PACE, which will allow you to access up to $50,000 of very low interest loans to do your energy upgrade. They haven't confirmed if it's a new build or just upgrades. But again, there's the end of renovation. So this is another way around it. And hopefully as soon as Edmonton does it and it works, other jurisdictions will catch on. So again, other things that impact the cost of a Passive House. The skill of your design team, the cost of equipment, material, the local construction prices, available financing incentives, interest rates, future energy prices, individual preferences, basically the same things that impact the cost of a standard building. So there's still all the things you have to worry about, but there's definitely ways to reduce all of them. So Alberta has been slow to kind of update to new codes, but we are getting better. Like the 2011 one, which isn't shown here, was a 2011 NEC National Energy Code for Buildings, was only adopted in 2016. But the 2017 one was adopted last year. Late last year. So we are under the 2017. And the Alberta government has said that they will be adopting the code upgrades quicker. So the code changes are coming. So now we'll kind of go on to how does Passive House play well with others. So the definition of net zero is on an annual basis, on an average year, climate year, you will produce on site the same amount of energy as you consume. So it's a really good principle. The problem is if you don't put an energy efficiency requirement on that, it means that like if you live in acreage, your like 1950s acreage home is in theory net zero ready. It would just take like a 50 megawatt solar panel array, but if you have acres of land, you in theory could put a 50 megawatt solar array on your house and you would be net zero. You would produce on an average basis the same amount. As far as the grid goes, it makes it worse because you're exporting a lot of energy in the summer and you're importing a lot of energy in the winter. So from a grid point of view, it's not very good. So again, this is the Canadian Green Building Council have come out with a net zero energy project, building system, and it does have an energy requirement. But building using Passive House low energy building as the energy model and building to net zero would kind of be the best way to go. So they work hand in hand. And basically Passive House Plus is net zero. So next is LEED. So LEED is Leadership in Energy Environmental Design. It's been around for probably about 15, 20 years, and it has done great things in North America on increasing the access to low VOC materials, recycling on site, a whole bunch of other things. But it is a green building standard, it is a points-based standard, and it has points for a number of different areas. All those areas are good, but the actual energy and efficiency portion of LEED is always based on a percent better than code. So because code is still so low, you can be 50% or 60% better than code, get kind of your 20 out of 20 energy efficiency points for LEED, and still really not be that comfortable. So what we're saying, and actually what has happened in the States, is Passive House in the States and LEED in the States have gotten together, and they say if you build a passive house in the States, you get 31 free LEED points, which is basically the lowest LEED certified level. And basically, it gives you 20 out of 20 on the energy points because you are the most energy efficient building out there, because we are passive house is the most stringent energy efficiency standard, and it gives you kind of the other 11 points on indoor air quality, innovation, commissioning, stuff like that. So again, they're not competing. Passive house is the perfect starting point for a LEED building. So this is the embodied energy one. This is only about a year or two old. I think they only have like 10 buildings built to this standard, but it's again from the Canadian Green Building Council. They've saw the need and they've moved to it. So this is the zero carbon standard. And it's just a standard that requires you to account for the full life cycle carbon embodied plus operating plus actually decommissioning at the end life cycle carbon of your building. So if you build a passive house, you'll reduce the operating portion of that, and then you worry about the embodied carbon in your selection of materials, then it's a perfect combination for your low carbon or zero carbon building. So start with passive house, add on that. This is the Living Building Challenge. So this is the most aspirational green building standard out there right now. It is the most strict. It requires you to be net positive energy. You have to produce about 105% of your consumption, and they make you test it, like you take a year of your actual product's production to prove it. You need to be net positive on your water. So they actually make you into a water treatment plant and a sewage treatment plant. And there's a whole bunch of other requirements. So that's why there's, again, not many that are done this way. It is the most aspirational. The other big thing that it does is it has what's called the red list. So the designers of this have looked at a whole bunch of products, and they have deemed some that are too toxic or too damaging to the environment, and they are no longer allowed to be used in your building. So there's a list of red list products. PVC is on that list. And if you use that product, you can't become Living Building Challenge certified. Except they do say that because there's some exclusions, and especially with PVC, because PVC is what wraps all electrical wires. So you have to try to not use anything on a red list, or you have to write a letter and basically say, I have tried, and it does not exist in the industry a product that doesn't have this. The other interesting thing that Living Building Challenge does is it turns engineers and architects and designers into environmental advocates. To get certified, what you have to do is you have to write a letter, I think 10 letters, to 10 manufacturers saying, I would have used your product, but one of the constituents is on the red label, and I will not use it. So I actually think that's pretty neat, because the market will move to where they see the demand. So if they get enough of those letters and see enough of the times where they lost a sale, they might change their product. But if no one sends those things, they won't change a thing. So it's why it's an aspirational one. But it's, again, start with passive house and add on whatever green building goal you want. Kind of the last one we'll talk about is well or fit well. And this is a standard that deals purely with occupant comfort and occupant health. So it is more in the commercial realm, where again, remember all those comments from before where people in mechanically ventilated buildings are more comfortable and more productive. So if you have a fit well building, your employees might be more productive and happier and stick around longer. But again, you should have passive house as the background to it, which will guarantee most of the comfort benefits, and then you add on a few ones that you need. So again, it's not an either or, it's a how does passive house work with other ones. And then the last one is permaculture or kind of regenerative buildings. So permaculture is another kind of 8-day course if you wanted, but basically it is a way of looking at land or areas to create systems that work with nature, not against it. So you use permaculture for more of the land around it, and you stick a passive house building on the site. But that way you can actually regenerate the land. You can decontaminate the land naturally through plants, and you can increase the productivity, increase the carbon in the soil, increase the productivity of the land using permaculture. So now we've kind of learned all the things about passive house. Kind of what are your next steps? How do you actually go about building, we'll say, houses for the kind of the purposes of this course? So first of all, a lot of people like to jump straight into designing your house, putting your bedrooms, putting your windows, putting your bathrooms, all that stuff. What I'd always do with my clients is I always start with goals. And the reason you start with goals is your house, it's not about designing your house. You want to come up with goals and a vision of what your lifestyle wants to be. How do you want to live in and out of your house, on your land? What do you want your life to be? And once you have that a little more planned out, then you say, okay, how does my house help me achieve that? Otherwise, if you jump into straight building a house and don't think about that, you can spend $4 or $5 or $6 or $800,000, move in and you go, you know, I don't actually want to live in the city. I want to be on a farm. So think about that first. Understand what's important to you, do some research, and then also when you have your goals, you have your sustainability goals, you have your vision, you know what you want, it's a lot easier to pick your team. A lot easier to pick and compare what different people do well and don't do well and see how well that meets what you want them to do. You're the one paying the money, you should get what you want. And then the right design team can help you then find a house with your budget that meets all your goals. And the more kind of broad your goals are, like passive house shouldn't be a house goal. I want a sustainable, low energy house that allows me to save money on my utility bills or something like that. We'll then say, okay, then we should start with a passive house. And then if you say I want to have a lower carbon footprint, okay, well then we want to use materials with lower embodied carbon. If your goal is you want to have geothermal, then okay, we can design a house that uses geothermal, or maybe design 4 houses that use geothermal. Like you find out what your goals, and then you find something with your budget to meet those goals. And then at the beginning of the project, so some people in project management class might have seen this before. This is a table of, as time goes on, this is the available options that you have or choices that you can make, and this is the cost to make a change to a choice. And this is project time. So at the very beginning, you have unlimited options because you haven't made a choice, and those options, none of those options change the budget at all because you haven't picked anything. But as you move along, as you make decisions, as you make more decisions, you put more constraints on, and then it starts to cost you more money to make a change. So at the very beginning, that's where you want to look at all of your options. Do I want to live urban? Do I want to live rural? Do I want to use CLT? Do I want to use earth bags? Do I want to use blown cellulose? Do I want to live in a condo? Do I want to renovate a house? Do I want to build a new house? Do I want to move an old house onto my lot? Look at all those options at the beginning. And this is like a very optimized, nice, smooth graph. It isn't smooth. As soon as you buy land, a whole bunch of decisions get made for you. A whole bunch of constraints get put on you, and a whole bunch of potential costs go up to make changes. So you want to make sure you actually buy the right land that meets your goals. Again, if you buy a land that runs east-west and has no self-exposure, you're limiting yourself to how much sun you can collect. If you buy a land that runs east-west but is a vacant lot beside you, like, okay, this is great, it's a vacant lot. Well, is it going to be a vacant lot now, or is it going to be a vacant lot in 20 years? But once you pick a lot, until you pick a lot, you don't really want to go too far down the house design, because the house design does have to be matched to the lot, to some degree. But once you pick the lot, you look at how the sun reacts on the lot, looks at maybe how the wind reacts on the lot, if there's any high points, low points, if there's drainage issues, if there's flooding issues. We bought our lot 3 weeks before the 2014 flood. We are 3 blocks from the riverbank, so we were actually a bit concerned. Fortunately, we are 5 meters higher than the river pathway that didn't flood, so we are fine. But we forgot to look at floodplains when we bought our house, because never floods in Calgary. Why would we want to do that? Well, you do. And again, once you have your lot, then you can start to optimize the layout and the placement of the house to that lot. So the next big question is, do you want to build new or do you want to renovate? So from a carbon point of view, and actually often from a cost point of view, renovating will be your lowest embodied carbon and often your lowest cost. Because again, you're not throwing away all that stuff that's already built. And if the bones of the house is good, if the orientation of the house is good, the layout of the house is good that you like, then renovation is often a very good choice. These are one example, and then we have another slide about the EnerFit standard, which is the renovation standard for passive house. These are in England. So again, most renovations will insulate to the outside because that's easier from a thermal bridging point of view. Looking at that stone facade, I'm guessing they insulated to the inside, so it can be done. And again, look, they got to 0.7 air changes, and they're right on the edge. They're at 27 when they're allowed 30 for the energy. But again, that's a renovation of probably like a 600-year-old house. I don't know, that could be a very old house, but its bones were good, so it was worthwhile to keep around. This is one in Minnesota. Look at that air changes. Like, you're scared of 0.6, that's 0.1. So they probably, my guess is they use what's called AEROBARRIER, which is kind of an aerosol-based air tightness system. So basically you take everything out of your house or protect all the surfaces, they spray in kind of an acrylic mist, and then they pressurize the house. And then the acrylic mist goes into all the cracks, starts to stick together to itself, and seals all the cracks. So basically, the longer you run that mist, the lower your air tightness gets. And then wherever you want to stop paying, they turn the machine off. So coming in a little bit closer to home, this is a Calgary company called Solar Homes, owned by Peter Darlington, who is a certified passive house consultant. He uses PHPP in the background of everything he does. He doesn't always design all the way to 15. He's probably designing again to kind of the 25, the low energy building standard. This is his house that he started with. So before he became a certified passive house designer, he was a siding guy, or an EIFS and a stucco guy. So what EIFS is its exterior insulation finish system. It's basically a membrane or troweled on membrane that's your air and vapor barrier, or can be your air and vapor barrier depending on what you want. And then it sticks on EPS foam. It has grooves in the back to give you a drainage layer to let the moisture out. It puts sticks of foam on, and you can do 6 inches, you can do up to 12 inches of foam on the outside, and then he puts basically stucco on the outside. So it looks like stucco building, but it's got, in his case, 6 inches of insulation behind it. So that kind of costs about $15 per square foot of wall, which is about 40 grand on a average size house. Then he also blows more cellulose into the roof, increases the air tightness of the roof, and then depending on the lot, as best he can, he excavates around the perimeter, puts some insulation below grade on the foundation walls, and then depending on what the ceiling height in the basement is, he will put a few inches of foam on the inside to insulate the slab. So that's how he does the envelope, and he replaces it. He doesn't use passive house certified windows, he uses Lux windows. So they are a very good triple pane, fairly sealed PVC window, but it's very cost effective. So again, he models it all and it works. So that's kind of your step one, is doing the envelope. And then he prefers that it kind of lives through a winter to see how much exactly the demand for energy has dropped. And then he will put in a correctly sized air source heat pump that runs to a hydronic coil that gets stuck into where the furnace was. You pull the furnace out, you use the same ductwork. You put this hydronic coil in there, you put a fan before it, you put an ERV or an HRV before it so that it supplies you the fresh air. The fan blows the air over this hot water coil, and that's now your heat for your house. So again, you're using as much as you can, but you disconnect from the gas line, you put in this air source heat pump. At the same time, you put in an air source heat pump hot water tank that kind of lives inside your basement. And then the next phase, if you want, would be to put on solar panels to get you net zero. So those are kind of the three stages of it, and it costs kind of $100,000 to $150,000, depending on how many rebates. Like when all the rebates were around, he could get it almost down to $60,000 to $80,000. Now that most of the rebates are gone, he's come back up. But that's what's called a deep energy retrofit. So again, you like the house, you like your location, but you're not comfortable. So you renovate. This is another family's house that he's done. Again, he stuck our 6 inches of EFIS on the outside, basically the same procedure as before. It was a kind of a single-story bungalow. The family liked the location, wanted to stay there, but weren't comfortable. Even closer to home, this is Butterwork and Renew Engineering. So this is Stuart Fix and Peter Amarongan's new company, along with Peter Butterwork. And this is Stuart's house. So what he did is, it's called a chainsaw renovation, or renovation. So what he does is he cuts off the soffits of the old roof, puts a new roof truss and new insulation on top. Because that's, depending on how big your roof is, that's the only way to get enough insulation on the roof to get to the R values that you need. And then again, you put insulation on the outside, went along, and look at his air changes, 0.25. Again, he probably used AEROBARRIER, but he might not have. He's been doing this for a long enough time that he probably knows all the tricks for air sealing to not need AEROBARRIER. But can be done. They are doing it. Here's another one. This is completed. This is an old photo. This started as a single-story bungalow. So it's a deep energy retrofit and a fairly large renovation. They added a second story, and even there's a small roof deck on the other side. This is the north face. The south face is one that has all the solar panels on it. The owner of this is the technical director of All Weather Windows. So he has, I think, 9 of the first vacuum glass windows in North America installed. So vacuum glass is what it says, is the vacuum between the 2 panes of glass. You can get very high R value with not much thickness, as long as you don't lose the vacuum. The other interesting part of this one is because it's all weather windows, he actually used the door cutouts from doors. When they put windows in a door, they cut out an insulation. So all that insulation stacked up, and I think he used like 6 months supply of door cutouts, and that's what's the insulation all the way around his house. So again, can't be done with everyone, but it's a good low embodied carbon because it's otherwise a waste product. And then you put harding on it, and yeah. So this is kind of what a lot of conventional designs look like, a lot of jigs and jogs and 45 degrees and angles, and I don't know which way south. It would be hard to make that passive house. The one beside it is my main floor. So it's a rectangle. It's a boring rectangle, but because of that, it's easy to tell which way is south, where there's more windows. I have one west window. It does overheat my house. It gets an 80% screen on it, basically the whole summer. I have no east windows, and my 2 north windows are 4x4. It's just enough for fire exit and visibility. But keeping that simple is how you keep the cost. And again, I still have in 1,150 square feet, I have 2 bedrooms, a bathroom and a half, a very large kitchen and a living room. Because I don't have a bunch of 45 degrees, I don't have any hallways, so it is a very open floor plan. But if that's one of your values or one of your preferences, then you design your house that way. If you want a more closed off floor plan, then you design it that way. But anytime you put more hallways in, the hallways are floor space that you're just going from A to B in. You can't live in that actual hallway. So every room, again, in passive house, every room is comfortable all year round. If you build a basement, move a bedroom into the basement, make the entire house smaller. I kind of mentioned all these things before. A slab on grade with no basement, if you have a lot of space, is most cost effective. A 2-story is less expensive than a 1-story of the same area, because again, if you have 1 story, basically everything is an exterior wall. Once you take half of that story, put it on top, a whole bunch of what used to be roof is now the middle story, so it's no longer an exterior wall. And again, building materials, think about it more. You are paying more for it, but they are higher quality, they are more durable, they should last longer. They should require less maintenance. Like Hardy Panel is an excellent example. It's fire resistant, it's mold resistant, its paint warranty I think is 15 years, and it also doesn't cost much more than vinyl. Like it's the second cheapest siding from vinyl. So that's why everyone is kind of moving towards Hardy, or fiber cement. There's a few other competitors. But again, it's a whole bunch of different colors, a whole bunch of different textures. And again, the interior design, whatever you want. You can spend as much or as little as on it. It makes no difference. A little more about the Canadian context. So if you keep it simple, what people are more used to doing, this is One House Screens wall system. So they use 2x8s instead of 2x6s. They then fill that cavity with blown cellulose, stuff that people are used to doing. On the exterior, that green stuff, instead of being plywood, it's a Canadian-made wood fiber board. It does take a bit of structure, so it can do some of your shear. It is very vapor open. The green stuff is actually a wax that makes it, water resistant. And yeah, then that third one is if they do, their OSB is taped as a vapor barrier, and that wall is the wall where they had to put more insulation because they didn't, that was on the one where the east-west building where they didn't have the south walls, south windows. But again, it's all kind of typical materials used in maybe a slightly different way, but stuff that carpenters and trades are normally used to working with. So finally, 5 principles: interconnected, interdependent. Got to use all 5. You can't just pick 3 or 4. So as the next steps, if you're just a homeowner, you hire someone. If you want to become a certified passive house consultant or a certified passive house designer, those are both the exact same routes. The only difference is if you're an architect or engineer, you're a designer. If you're a plumber or a painter or not those other 2 things, you're a consultant. I don't know why they made a difference, but they did. That is about a 6 to 8 day course and then you take a test and then you get the designation. The other option is if you're more of the tradesperson on site, you take, I think it's about a 4-day course, and then you become a certified passive house tradesperson. So you learn how to do all the tapes, do all the HRVs, the windows, all that good stuff. This is a little more southern Alberta centric, but these are some of the number of passive house certified designers and companies that you can call to help. There's obviously a lot more people in these. These are just some of the ones that kind of we know and helped on this course. These are some websites you can go look at. So Passive Buildings Canada, they are kind of an agnostic green building group. You don't have to be passive house, you don't have to be anything. As long as you're building a good building, you can get on that website. They have a lot of free material on these topics and a bunch of other these topics on their website, so you can go spend a few days looking through all their stuff there. Passive House Canada is kind of the national body for representing passive house in Canada. Passive House Alberta, we just worry about Alberta. Again, if you become a member of Passive House Canada, I think it's about $200 or $300 a year. You also then become a member of Passive House Institute. That's the home base in Germany. And when you're a member of them, you get access to their database of all the Passive House certified building materials, Passivepedia, a whole bunch of questions and answers and other information. And both Passive Buildings Canada and Passive House Canada have a long list of certified passive house designers by area that you can go and look at. Thank you to our sponsor, Energy Efficiency Alberta. Without their grant, we would not be here. And then thank you to our introductory sponsors again. Their support is very meaningful to us. It helps us continue with our jobs, or with our education mandate. And we believe in the products that they sell very well exemplify all of these principles. And that's it. So stay in touch. It's not the end of the conversation. The whole point of this is to start the conversation. Any questions you have can go to education at Passive House Alberta or myself directly. We have a newsletter. We have membership, the membership for students. Join us on social media and stay in touch.